Hey everyone, what is happening? Well, today we're going to be talking a little bit about polyatomic ions. Now, poly means many. And when you think about many, it means many atomic ions. Well, it means it's got many atoms and they are an ion. So polyatomic ions are made up of more than one type of atom joined by covalent bonds, meaning that they're sharing electrons. Some examples of polyatomic ions are CO3 with a 2 negative as its charge, and this is called carbonate. We've also got OH negative, which is called hydroxide. And we also have a positive polyatomic ion, which is NH4 with a positive charge, and this is called ammonium. Now you may be wondering where you can find these, the names of these. I'm never going to ask you to memorize these. They're actually in your data booklet. So it looks like this on your data booklet. You've got your periodic table of elements that you have been looking at, and just if we go down a few pages, we can see the different polyatomic ions. All right? And so it gives them to you, and you can find them there. So polyatomic ions are always paired up with ions that have an opposite charge. So if you look back at that sheet that I just showed you, you'll look at the charge of those ions. Now it means that they don't break up, they act as one. So for example, hydroxide, OH negative, would pair up with a positively charged ion, and ammonium, NH4+, would pair up with a negatively charged ion. Now let's just do a quick example. If we go NH plus and OH minus. What that says, because it's a polyatomic ion, it doesn't break apart and it acts as one. So we swap and drop, which we did last class, and we get NH or NaOH, and it acts as one. Next, if we did with ammonium, so we've got NH4 plus. That whole thing, that whole NH4 plus has a positive charge. And we're going to add it to chlorine, which is a negative. We would swap and drop that. And it means that we have an NH4 and a Cl. That 4 tells us that there's 4 hydrogen atoms in that molecule. Now, there's a few rules for writing formulas for compounds that contain polyatomic ions. First off, we figure out which ions are present and what are their charges. So we look on the periodic table for these and the sheet that I just showed you, and it looks like that. And so we'd look through there and find the polyatomic ion. Next, we swap and drop our charges just like we did above, and we're going to get a little bit more practice doing this. Now, if you have more than one particular polyatomic ion, you must use brackets and write the subscript outside of those brackets. And so what we have is we're going to do an example of that, Mg2+. We've got magnesium there, and we're going to add some ClO to that. ClO, if we look on our sheet, ClO is, and it's got just a minus there, and it's hypochlorite. So this is going to be magnesium hypochlorite, and it's got a negative charge. So what we're going to do, if we follow these rules, we figured out our ions, all right? And now we're going to swap and drop. And we get Mg, and that's just a 1 down there. And then because we have a 2, we're going to go ClO, and we're going to put it in brackets. And what that tells us is that we need 2 ClO polyatomic ions to balance out our Mg2+ ion. Now, when we're writing names for compounds that contain polyatomic ions, first ion is always the metal, and we keep its name. If the first ion is a polyatomic ion, it also keeps its name. If the metal is multivalent, it needs Roman numerals, and we went over that last class. Now, if the second ion is a nonmetal, it gets an "-ide". If the second ion is a polyatomic ion, it keeps its name. So let's get some practice here. we've got Mg plus ClO3. Well, we've been given our ions and we know the charges. So let's figure out what we're going to get when we swap and drop. So I'm just going to rewrite it so that we've got a little bit bigger. Mg2 plus and ClO3 2 minus. We're going to swap and drop these charges. And because they're the same, we can cancel them out, so we get MgCO3. Now let's use these rules. So if the first ion is a metal, we use its regular name, which is magnesium. And CO3, let's look on our sheet. CO3, we're going to go there. CO3 is carbonate. So we're going to go back and we call it carbonate. So what you notice is we've swapped and dropped our charges. We came up with our compound and we named it according to those rules. So next we've got K2Cr2O7. Well, if we look on this sheet, we've got Cr2O7 is dichromate. So what we're going to do is we're going to find our charge. So we had K, and if we look on our periodic table of elements, and we've got potassium over here, is a plus. So we're going to get K plus and Cr2O7 with a 2 minus. Well, we found out our ions, and now we're going to swap and drop. And we're going to get K2Cr2O7. What that says is we need 2 potassium ions to balance out 1 dichromate ion. So we've got potassium dichromate. Next we've got FeOH3, and that says we've got an Fe, we reverse swap and drop, and we've got a 3 plus, and our OH ion is a negative. We can bring this back up there and bring that invisible 1 right back up there to find out the charge on our ions. And it's very important that when we have metals that we know the charge, because sometimes on the periodic table, just like we're dealing with Fe there, Fe has 2 charges. So we need to be able to state what charge we have. And going back to our multivalent metals from yesterday, we've got iron 3 hydroxide. And that 3 tells us what charge is on our iron. I'd like you to try these next 2 on your own. Please bring them to class. Have a good rest of the day.